Hey class, Mr. Pusky here. Hope you're having a good day so far. This is our first lesson, which is 1.1, and it doesn't have the name of the lesson on the assignment, so let's go ahead and read this together, which is the name of the lesson, which is, ready, 1, 2, 3, real numbers and number operations. So because we're doing this digitally, I like to try to simulate what we do during class. So usually what I like us to do is to read the name of the lesson together, and then the essential question too. I am borrowing notes from somebody, so the essential questions are kind of a lot to read, so I'll probably give you a second to read those on your own, or I'll read them out loud to you actually as well. But so the way notes are going to work for us, I'm going to record smaller lessons, videos that are going to go through the notes, and you guys are going to take notes on the packets that I gave you for the beginning of the year. Later on, we will probably be taking notes on our own on, just on paper itself. So, yeah. So, we'll get into it for now, and if you guys have any questions, feel free to email me or ask me questions during class. So, basically, every day we don't have class, we're going to have a lesson posted, and it'll be your responsibility to watch the videos and to do the homework that's assigned. Okay? All right, so I'm going to read through the essential questions so you guys can hear them out loud. Number 1 is be able to describe sets of numbers and give the correct notation for each set. Be able to determine which set of numbers a given number belongs to. Be able to use addition and multiplication properties of real numbers. Be able to identify properties of real numbers. Be able to perform operations and give answers in appropriate units. Okay? So I don't know if you guys are aware of this, but you guys probably use a few numbers since you've done Algebra 1 and Geometry, and now you guys are in Algebra 2, but there are actually like different sets of numbers, basically like, categories that numbers fall under, okay? So we're going to fill in this table, and then we're going to take some time, and we're going to actually draw a graphic organizer, which I'm not a huge fan of in general, but this one makes a lot of sense and will be very helpful for you, okay? So we're going to fill in these blanks here. So we have notation, name, and definition. We're filling in the different sets of numbers. So what we call any number that can be represented on a number line, those are called, if you know what they are, you can say it out loud for me, but they are called real numbers. Real numbers. So any number that can be represented on a number line, that would include 1, negative pi would be a real number. 0.1, 2, 3, 4, etc. Square root of 17 over e would be a real number. E is actually a number we're going to talk about more this year with logarithms and natural logs and that kind of stuff. Okay? The notation for real numbers is kind of this double R. You can watch how I do this. I'm going to do 2 vertical lines, and then I'm going to make an R out of it. Do that one more time. 2 vertical lines and make an R out of it. That's called, the notation for real numbers is a double R, kind of like that. Okay, awesome. You guys are doing great. I can't see you or hear you, but I know that you're doing a great job right now, okay? The next one, no fractions 0 or greater starts with a whole in quotation marks. Those are called whole numbers. Whole numbers. And there actually is no notation for whole numbers. Yeah, some people use a W, I guess, but from what I've seen, there's no notation for it. So it starts with a whole, 0 or greater. So 0, 1, 2, 3, etc., and so on. It's kind of like counting numbers, but not specifically counting numbers because they start at 0. Okay? Next, no fractions, positive, negative, or 0. Do you guys know what kind of numbers those are called? So, for example, that would be like negative 13, negative 2, 0, 700, 1 million. What kind of numbers are those called? It starts with an I. Those are integers. Integers, positive and negative whole numbers. And the notation we use for integers is a Z, and it's kind of a double Z like this. That's really bad. I'm going to fix that. It's like a double Z like that. Okay? All right, counting numbers. Like we were talking about whole numbers, but this one starts at 1. This is going to be 1, 2, 3, 4, and etc. going on. Those are called, naturally starts with a 1. Those are called natural numbers. Natural numbers. And the notation for that is going to be an N. It's going to be this kind of double N. It's going to go over and down kind of like this. Let me fix that. It's hard to draw in here to draw it nicely, but I'm having a rough time, guys. There's kind of a double N like that. Okay, natural numbers are counting numbers. 1, 2, 3, 4, etc. Okay. So can be written as a fraction. Those are numbers that can be written as a fraction. Another name for fraction is a ratio, and it's decimals that will repeat or terminate. So it's going to be like 1/2, 0.3 repeating. It's going to be 11. It's going to be -6.3, 3 1/5. What kind of numbers are these? Think of the word ratio. Those are going to be rational numbers. And the notation for that is kind of a Q, is kind of a double Q like this. Okay? So that's kind of weird. So these are all numbers that can be written as a fraction. Well, what is 0.3 repeating as a fraction? What is that? Yeah, that is going to be 1/3. That can actually be written as a fraction as 1/3. So any repeating fraction or any repeating decimal like that goes on forever, even though it goes on forever, you can still write it as a fraction, right? 11. What is -6.3 as a fraction? That's weird. It's 6.3. It's not a whole number. Well, this is -6 3/10. Or if you convert that to a mixed improper fraction, that's going to be -63 over 10, right? Same thing over here. 3 1/5 is the same thing. Convert that to an improper fraction, multiply and add up here. 3 times 5 is 15, plus 1 is 16 over 5. So these, even though these don't look like traditional fractions, they can be written as fractions. All right, and the last one, there's rational numbers. There's also what are called numbers that are not rational. Those are called irrational numbers. Irrational numbers. So what's the most famous irrational number? Do you guys know? Starts with a P and ends in an I. It is pi. Also, numbers that are square roots that are not square roots of perfect squares. Square root of 2, square root of 7, stuff like that. I'm going to put or any non-perfect. Okay. Also E, like we talked about before. E is like 2.71 repeating, going on forever, does not repeat. So yeah, those are all examples of irrational numbers. And there is no notation for irrational numbers. All right. So there's our table. Very nice. Looks very, very nice. Cool. So we are going to take a second before we do the examples at the bottom. We're going to take a second. I'm going to open up a new page. And we are going to make a graphic organizer to help us organize these numbers and make them into a nice table kind of thing that will help us. So not that. I want to do this. Okay, can I rotate this? Should have figured this out beforehand. I haven't had to do this before, but all right, anyways, we'll go ahead and do it anyways. So I'll open this to full page. Okay, so we are going to do sets of numbers. Okay, so I'd like to write this on the back of your 1.1 notes. There should be some room, either during the summary you could use if you're going to be doing that for your Cornell notes, but on the back of that page there should be a blank sheet of paper. Otherwise, you can just get out a blank sheet of paper and draw this out for me, okay? So here we're going to draw a graphic organizer. Like I said, we're going to draw a big oval like this. Okay, Let's fix that. It's a little crooked. Circle works. Okay. So sets of numbers. The biggest category of numbers are going to be called complex. Complex numbers are going to be combinations of real numbers and imaginary numbers, which we're not going to talk about yet. We'll get to this later in the year. But complex numbers are the biggest category of numbers. And then over here, let's draw a little circle like this. This is going to be then there's imaginary numbers. Okay? Another subset of complex numbers are imaginary numbers. And then under that, I'm going to draw another kind of big one. Okay? And then under that, we're going to have our real numbers, or our double R. Okay? So we have real numbers. And then what things make up real numbers? What are all numbers on the number line? Well, we have rational and irrational. I'm going to draw irrational kind of small because those are, and this doesn't represent that there's less numbers that are irrational. There's infinite numbers for all these for the most part. It's just that we need to fit more things inside of the circles here, okay? All right, so there's irrational numbers. And then there's also rational numbers. And that is going to be Q. Okay? And then rational numbers, we have three sets of numbers that make up rational numbers, numbers that can be written as fractions. So what we have first, what do you think comes after rational numbers? So rational numbers include numbers that are any numbers on a number line that can be written as a fraction. So do you think we're going to put whole numbers or natural numbers first, or what do you guys think? What do you think the number is going to go first under rational? What has the biggest set of numbers involved? Integers, whole numbers, or natural is what's left. It's going to be integers, right? We're not going to pick natural because natural only has 1, 2, 3, 4 going on to forever, but integers is positive and negative whole numbers, right? So obviously we're going to use integers because that has more numbers involved. All right, what do you think? We have two options left. We have whole, or we have whole or natural. Which one has more numbers in it, whole or natural? What do you guys think? There is some overlap, but whole numbers has 0 and natural does not. And there's no notation for whole. Actually, I should have changed that color. And the last one we're going to have underneath whole numbers is natural. And that was the double N. All right, and here's our nice table of concentric circles, kind of the different types of the different types of numbers and different sets of numbers. Okay. So basically, anything that's all the numbers that exist fall under complex. Okay. Then there's real and imaginary, right? And then under real, there's rational and irrational numbers. And then under rational, integers, whole, and natural numbers are all types of rational numbers. So what you would do, so if we go back to our, like an example, so say we're trying to figure out where -7 would be, okay, -7. Well, -7 is a negative whole number, right? So what type of what type of number would that include? What would be the most specific definition or set of number we would use? Well, it's going to be an integer, right? So because it's an integer, it's also a rational, it's also a real, and it's also a complex number. It's not going to be irrational or imaginary because those are kind of their own things. Don't fall underneath the circle there really. But yeah, so because it's a negative whole number, it's going to be an integer, it's going to be a rational number, and it's going to be a real number, and it's going to be a complex number. Okay? So there's your, so make sure you keep this in a safe place. We're probably going to be referring back to it later. There's a few of these online too, but I thought do it this way might be a better way to do this. Okay? All right, sounds good. So let's go back to the actual lesson now. And I want you to pause the video and go ahead and try to do 1, 2, 3, and 4. Try to figure out which sets of numbers each number is a member of, okay? So find its most specific name, and then go ahead and figure out all the sets that it belongs to. Pause the video and try that. Okay, welcome back. So for 14.2, that is a positive decimal, and the decimal ends or it terminates, right? So this is the same thing as 14 2/10, right? So that it's a decimal and it's positive. It could also be written as that's 142/10. Okay, so that's a ratio. So it looks like the most thing we can write it as is a rational number. So it's going to be Q. It's also then a rational number. It's also going to be a real number. And then everything falls under complex numbers too. I should have mentioned a complex number is a combination of real and imaginary numbers. We haven't really talked about imaginary numbers. We're going to get to that a little bit more later. But just don't panic about that right now, okay? So there's your answer. Those are the sets that it belongs to. All right, this one's kind of tricky. Cube root of 5. The cube root of 5 is saying what number times itself 3 times equals 5. So the cube root of 64... that's going to be 4 times 4 times 4, right? So the cube root of... I put a 4 there. I shouldn't have done that. It should have been a 3. The cube root of 64 is going to be 4. So that would be a nice... That would be a what you call it? A rational number. Or an integer even. It'd be an integer. It actually would be a lot of numbers. But but for this one, the cube root of 5, there's not a number you can multiply by itself 3 times to get 5, because 5 is a prime number. So for this one is going to be what's called irrational, because you can't write it as a fraction. It's going to be a real number, and it's going to be a complex number. Okay? -12, that is a negative whole number. So for that one it's a negative whole number, so that's going to be a integer. It's going to be a rational number, a real number, and a complex number. But the most specific definition is a integer. Okay, and the last one, 34. That one is a counting number, so that's going to be a natural number. Oops. Natural number, a whole number, integer, rational number, a real number, and complex. So sorry I forgot to mention that like Z and Q don't really make sense for why those are called that. It's just a notation that mathematicians chose to use, just kind of like they use M. Remember how when we were solving for slope of something, they called M slope, like y equals mx plus b, slope is m. That's kind of just a random letter. It's the same kind of thing. So these notations don't really make a lot of sense for integers and rational numbers, but don't panic over it. Just something you kind of need to know, okay? All right, so I'm going to stop the video there. We'll finish. We have 2 more sections, 2 more videos to do in this lesson, and then we'll be able to call it a day. So thanks for watching.